Hello, this is Mr. Holly. We're still looking at Lesson 2 of Module 3. Today we're on Day 2, and we are going to begin to look at some word problems and take a look at how to use expressions to solve problems and to model those problems. So our first problem is about a chair that is X meters long and a table that is 4 times as long as the chair. You probably have a little typo here. That should say chair. Draw and label a diagram for the chair. So I drew a chair and a table, and what I'm going to have here is a chair that is X units long, and the table that is 4 times as long, which would mean it would be like 4 of those X's. That's 4 times the size of the chair, 4 times the length of the chair. How could I write an expression to represent the table and the chair? Well, table and the chair, so we're thinking about adding those distances together. So X plus, this is 4 times X, or 4X, and I could also express that as 5X. That'd be equivalent. Now, we're told that the total length is 15 meters. So is 15 meters, this tells me that something has the same value as my expression. When two expressions have the same value, we could say that they are equivalent. And if things are equivalent, we can create an equation. That's what the second half of this module is about. But here we're still going to be able to use equations occasionally when necessary. So because this is equivalent, 5x is 15 meters, so it's equivalent to 15 meters. So now I have an equation, and this is a one-step equation like you solved in 6th grade. We want to know what the value of 1x, which would be divide by 5, and x is equal to 3. Now, the question is, how long is the table? So I would need to remember that the table was 4x, so I'd have to come back. I could substitute 4 times 3. The table is 12. Or potentially you just want to look at, you have this diagram where you had the chair was x and then the table was 4x, right? Well, if the whole thing is 15, that means each box is going to be worth 3. So 3, and then you could just kind of count 3, 6, 9, 12. So this is 12. That's the length of the table is 12. Okay. Move on to the next question. The next question is about Margot. It says that Margot uses a processing fee of $3 to rent a storage unit plus $17 per month to keep her belongings in the unit. What expression models Margot's payment per month? So when we're writing expressions, we usually have, like some number times a variable, and then we usually have a constant term, which is just like adding an individual number. When I see a coefficient and a variable, that's telling me that there's multiplication happening. Some unknown value is being multiplied by some amount. So in this case, I need to identify what is being multiplied. That's what's going to go with my variable. So let's see. Margot pays a processing fee of $3. Does she pay that fee many times or just one time? It looks like this is a one-time fee. So $3 is kind of on its own. But then it says she pays $17 per month. This tells me that 17 is being multiplied by the number of months. So if I wanted to express her total cost, I could say that she pays $17 for every month, plus she paid that $3 processing fee. So there's an expression that models Margot's payment per month. And we could substitute in a number of months to find the cost. 10 months, substitute in 10. That's $170 plus 3, $173 for 10 months. We could substitute into this expression to evaluate what it would actually cost for a certain number of months. We've modeled it with an expression. Okay, let's come down to the bottom. Margot's friend Carissa wants to store a box of her belongings in the storage unit and tells Margot she will pay $1 towards the processing fee. So here's how I'm actually going to talk about her friend. Is I'm going to take our original expression of 17m plus 3 and I'm going to modify it based on what Carissa says she's willing to pay. So it says Carissa will pay her $1 toward her processing fee. Okay, so let's keep that by itself, and then $3 for every month. So $3 per month and $1 for the processing fee. Write an expression in standard form that represents how much Margot will have to pay for the storage unit for 1 month if Carissa contributes. So 17 was the cost per month. Carissa will pay 3 of that. So 17 minus 3, because Carissa is paying 3 per month, and it costs 17 per month. And she said she'd give her $1 towards the processing fee, so I'm going to come over here and I'm going to subtract $1 from the processing fee. Now, we're told that the number of months is just 1 month. How much will Margot have to pay for 1 month? Well, I could substitute 1 in for m. If I subtract there, that's going to be 14 times 1 plus 3 minus 1 is 2. And that's 14 plus 2, which is 16. So it would cost $16 for Margot to rent the storage unit if Carissa pitches in her $3 and $1. All right. Let's go to the next page. These are pretty straightforward, no word problems. We're just going to go through doing the basic operations, but it's going to include variable terms. So, negative 3x plus 8x. All right, they have the same variable. They're like terms, so I can add them together. 8 plus negative 3 is 5x. The sum of negative 7g and 4g plus 2. This should be in parentheses, but since it's addition, I'm going to leave them off because addition is commutative and associative, and I can add in any order and any grouping that I'd like. So I want to do negative 7g plus 4g. That is going to be negative 3g. These are the same. Have the same variable. They are like terms. There is no term like 2. It is the only constant, so my expression is negative 3g plus 2. Find the difference when 6h is subtracted from 2h minus 4. So I have 2h minus 4, and I'm going to subtract 6h. Okay? Now, because this is subtraction, I would like to rewrite it as addition, and that way I can, again, move the numbers and add them in any order I would like. So 2h plus negative 4, and then I can drop my parentheses. And instead of subtracting 6h, I'm going to add negative 6h. Negative 6h and 2h is negative 4h. These are like terms, so I can add them together. And then negative 4 has no term that is alike, so it will remain negative 4. All right, find the difference when this is subtracted from this. Negative 3n minus 7 is subtracted from n minus 4. Okay. Or n plus 4, excuse me. N plus 4 minus negative 3n minus 7. I'm going to keep n plus 4 as is. When I subtract negative 3n, I can change this to adding the opposite of negative 3n, which is plus 3n. I can change this to adding the opposite of 7, which is going to be plus 7. Now I have like terms. N and plus 3n makes 4n. 4 and 7 makes 11. 4n plus 11. Find the result when 13v plus 2 is subtracted from 11 plus 5v. So here I have 11 plus 5v minus 13v plus 2. All right? 11 plus 5v. I'm going to subtract 13v, or add the opposite of 13v. And I'm going to subtract 2, or add the opposite of 2. I can combine my like terms. 5v and negative 13v, they are alike. 5 and negative 13 is negative 8v. 11 and negative 2 can be combined. That is 9. All right. Find the result when negative 18m minus 4 is added to 4m minus 14. So I'm going to write this as negative 18m minus 4 plus 4m minus 14. I think I wrote that backwards, but honestly it's not going to matter because we're going to make everything addition, and we can add that in any order. So this is negative 18m, this is plus negative 4, this is plus negative 14. Now, negative 18m and 4m are like terms, so it's negative 14m. Negative 4 and negative 14 is negative 18. And here is our expression, negative 14m plus negative 18. The last one, what is the result when negative 2x plus 9 is taken away from negative 7x plus 2? So negative 7x plus 2 minus negative 2x plus 9. That would be negative 7x plus 2 minus the opposite, plus the opposite of negative 2x, which is a positive 2x. And since I'm subtracting here, I'm going to make this plus the opposite of 9, which is going to be negative 9. Negative 7x and 2x is negative 5x. 2 and negative 9 is negative 7. And here is our final expression. Remember to put squares around your variable terms and circles around your constant terms, just as a means of separating them and identifying what terms are alike. Okay, let's take a look at the last two problems here. We've got some word problems. We need to check very quickly on our time. Got 2 minutes, so let's run through these pretty quick. Marty and Stuart are stuffing envelopes with index cards. They put X index cards in each. Marty has 15 stuffed envelopes and 4 extra index cards. So there's X index cards in each envelope. If he stuffs 15 envelopes, that's 15X plus 4. Stuart, 12 stuffed envelopes and 6 left over. I need to write an expression that represents the total number of index cards. Well, that would be the 15 envelopes and the 12 envelopes, so 27x, the 27 envelopes, plus an additional 10 cards. All right, last problem as we run out of time. This shows me the area of a rectangle. The area is 24b feet squared. Remember, area is equal to length times width. So these are each the factors that are multiplied together to get this area. If one of the factors is 2b, what is the other factor? So I would think about this almost as if it were a factor tree. If you remember those, if I'm writing my factors of 24b, I could say 2b is a factor, and what else is a factor? 12. The way I think they would like us to think about this is area has to be divided by the length in order to get the width. So because this is 24b divided by 2b, we could think about it as 24b divided by 2b is the same as 24b times 1 over 2b, or 24b over 2b. The b's eliminate. 24 over 2 is 12, and here we have used the multiplicative inverse. Instead of dividing, we use multiplicative inverse. All right, hope this has been helpful to you. Let us know if you have any questions or need us anyway. So thank you, guys.